This is problem 541. AD is pinned, or I'll read the problem statement. It says the bulkhead AD is subjected to both water and soil backfill pressures. Assuming AD is pinned to the ground at A, determine the horizontal and vertical reactions there, and also the required tension in the ground anchor BC necessary for equilibrium. The bulkhead has a mass of 800 kilograms. So I went ahead, I just inserted the picture just for those that don't have the textbook, and wrote down some of the important things from that problem statement. So AD is pinned at A, it's in equilibrium, and the bulkhead AD has a mass of 800 kilograms. And so they want us to find AX, AY, and TBC. So as you all know by now, we're going to start with a free body diagram. So I'm going to draw that AD, which is the body that we're interested in. And then I'm going to start drawing the forces that we have there. So we have this distributed loads. These are in shapes of triangles. So the one from the water is going to be from this direction. And that force is going to be 118 kilonewtons per meter times 4 meters times 1/2, because it's that area. And if we multiply that out, that comes to 236. I'm having trouble with this iPad, this tablet. 236 kilonewtons. And then on the other side of it, from the soil, we have another triangle that goes up to 310 kilonewtons per meter. And so the value there is going to be 310 kilonewtons per meter times that whole height, which is 6.5 meters, and then times 1/2. Remember, this is a triangle, so it's 1/2 base times height, basically. And if we multiply that out, that comes to 1,007.5 kilonewtons. And then we also have that that force up here. I saw I called it something else. I'm going to change that to F, just because that's what they had labeled it there. So we don't know what F is. And then the last force that we have is they told us the weight of AD. So basically, if they don't tell us, or they told us the mass, which we can figure out the weight. If they don't tell us anything, typically we just assume that the weight of the bar, the beam, is negligible. But this one, they tell us that it's 800 kilograms. And that'll be at the center of it. That's that weight. That equals 800 kilograms times 9.81 meters per second squared. And so that gives us 7.848 kilonewtons. So it is a good bit less than the other forces we're dealing with. Then we need to go ahead and finish up our free body diagram. So I'm going to put in some of the dimensions. So the triangle on the left side from the water was 4 meters. So this height here would be 4/3 meters. Here's 1/3 from the heavy side. For this one, for the soil, it's 1/3 of that 6.5 meters, which comes out to 2.1666 continues meters. So we know the force here is 0.5 meters from the top. Trying to think of other things that we need to know. This whole height is 6 meters. We need to do our coordinate system. So we're going to have positive x to the right and positive y going up. I think that's it. Yeah, I think that's all we need there for the free body diagram. So now we've basically got our 3 equations and 3 unknowns. So we should be able to solve it. We have the sum of the moments about a point equal to 0. some of the forces in the x direction equal to 0 and some of the forces in the y direction equal to 0. So there are a couple of places we could start. I think the one that probably makes sense, oh, I didn't label this A, it's B up here, and then D up here. Let's do the sum of the moments about A. Oh, and I forgot a force. So at A is a pin, so we have AX, let's see, AX, and then AY also. I took a guess at those directions because the force from the soil is so high, it's the 1,000, over 1,000 kilonewtons. I'm guessing that the AX will need to go to the right to counterbalance that, but it's just a guess. And then AY, we have the weight coming down, so I assume AY is going to need to go up to counterbalance that weight. So I'm going to sum the moments about A equals 0. And I picked that one because we know the least about A. Or we have two unknowns at A, so we should be able to solve for F if we do it this way. So sum of the moments about A, so we have, and let's do coming out of the board is positive, so that 236 kilonewton force. If we do our hand from A up to that force, do our fingers in that direction, my thumb's pointed into the board, so that's a negative moment. So negative 236 kilonewtons times that moment arm, which is 4/3 meters. And then the next force up is the force due to the soil, that distributed load. That one, if we do our right-hand rule, we see that it's positive. So positive 1,007.5 kilonewtons times that 2.166 meters. And then that weight is just in line with it, so there's no moment arm, so that doesn't create a moment. And then we go on up to the force, which will also give us a negative moment, so negative F times, and that's 6 meters from A. That equals 0. And so if we calculate that out, we end up getting F equal to 311.4 kilonewtons. So that's one of our unknowns. So I'll go ahead and box that. So, and maybe I'll write it up at the top too in our free body diagram. So this F equals 311.4 kilonewtons. Now we have two more equations and two more unknowns, so AX and AY. So let's start with the sum of the forces in the y direction, just because this one's going to be easy, equals 0. We have AY, which is pointed up, so that's positive, and then minus that weight, which is 7.848 kilonewtons, equals 0. And so we get AY equals 7.848 kilonewtons. And that means we did pick the direction to be right. It's pointed up. And then we can sum the forces in the x direction equal to 0. So sum the forces in the x direction equals 0. We have AX. It's going to the right, so we're calling that positive. And then that 236 kilonewton force is also to the right, so plus 236 kilonewtons. And then minus the one from the soil, which is 1,007.5 kilonewtons. The weight's just in the y direction. It doesn't have an x component. And then that force will be plus, that force is 311.4 kilonewtons. So we had 1, 2, 3, 4 forces. So I'll just go through and count them. Let's see. I have 1, 2, 3, 4 forces in the x direction. We had 1, 2, 3, 4. So we're good there. So this equals 0. So then we can just add those up. And we get AX equal to 460.1 kilonewtons. We got a positive number, so that means that we'd guessed right, so it is to the right. And there's our answer.